Welcome to ProgrammingKT. Today in this tutorial I am trying to explain about queue interface and its implemented classes. In previous videos I already explained about list interface and its implemented classes, set interface and its implemented classes. So if you did not watch watch that video, you will get some clarity on list and set and its implemented classes also. So now let me try to explain about queue interface. So queue follows FIFO rule. So this is the first point you need to remember when we are talking about queue. So FIFO is nothing but first in, first out. And moreover that when you are talking about stack, so you need to remember last in, first out. So here vector child class is stack, right? So stack. So stack follows LIFO. So LIFO stands for last in first out. Stack follows last in first out rule. Queue follows first in first out rule. So if you are trying to provide some public service in real time also, right? So then there are n number of people. In that case, if you are trying to provide that service, so we need to follow queue rule, right? So who is coming first, that person will exit first. So we can call this is the enter and this is exit. So we can consider this is the queue. So first person, second person, third person. So this is the queue. So these queue data structure and stack data structure coming from real time only. So enter, exit. So imagine some VIPs are there. In that case, so if the inside queue, three members are already there. Imagine not only three, n members are there. In that case, some VIP person will be there. Will come. So in that case, this VIP person will get higher priority, right? In that case, all these 3% still inside that queue only. First, we will serve this. We can provide services to this VIP person. So, last person is VIP, even though some peoples are there, right, to provide services. But VIP is there. We can give highest priority to VIP. Then he will exit it. So this is called priority queue. Queue also some types are there, right? Priority queue, priority blocking queue, array queue. We can implement by using linked list also queue, this kind of thing. So this is one type of queue. Priority queue. Who is having highest priority, we can serve first, like this. Now let me try to explain about how to implement stack and queue. So either it may be stack or queue, we can implement in two ways. So by using linked list or by using array. So what is the advantage and what is the disadvantage? Let me try to explain. So either it may be stack or queue. So we can implement in first approach by using linked list. So second approach is array. So queue also same by using linked list. And second, first one, this is the first one. Queue we can implement first approach is by using linked list, and second one is by using array. Let me discuss what is the advantage and what is the disadvantage. So queue is nothing but follows LIFO, right? Last in, first out. So if it is last in, first out, so if you are implementing linked list, so in that case, some extra memory is required. So why? Because linked list contains two part, right? Each node contains two part. In that case, so for storing data, one part, inside that node, two parts will be there. First part is for data, second part is linked to the next node, like this. So comparing to array, it is required some extra memory, right? In array, there is no pointers, right? Directly you can access. So first disadvantage, if you are trying to implement stack by using linked list, extra memory. It will take extra memory. And second disadvantage is, so if you are trying to access element at third node, you need to follow sequential access, like this. If your linked list have n nodes, n times, you need to go sequentially. Random access is not possible. Time complexity is time complexity is high compared to array. So if you can implement the stack in array, so both you can, these two will be optimized. So extra memory is not required, time complexity also we can reduce. Why? Because we are trying to access element at index, I mean third element, index 2, directly you can access by using index number, right? A of 2 like this. Anyway, in stack we don't have that, that feature. In middle element you can't access. So in array it is possible, but in stack that functionality we can't do. Why? Because it is not possible. Why? Because by using push and pop methods only we can add and we can remove. So imagine this is the stack. So if you are trying to add elements, always we need to follow push on top of only. This is the first element, second element, third element. On top only you can add, directly you can't add here in middle. So that is the behavior of stack data structure. And moreover that, if you want to remove, so you can always remove top element only. This is called push, this is called pop. So these are the two methods, for adding and removing. So stack. So if you are following stack data structure with array, so these two will be optimized. Anyway, time complexity I think remains the same. We can't say this is the disadvantage with the linked list and array implementing stack. Anyway, always you are removing and you are adding here, right? So in that case, so second point we can't ignore. But anyway, in the array we can access randomly, right? But in stack that is not possible. So we can consider only memory. So if we can implement linked list by, stack by using linked list, memory is extra, array memory is less. So always recommended approach is array. Next one is queue. So if you are same queue also, if you are trying to implement linked list, memory will be high, and moreover the time complexity anyway almost constant anyway. Why? Because it follows FIFO. So FIFO means in linked list if you can implement queue, almost same. If you are adding here elements and if you are removing elements here, this is the first, enter point, this is the exit point. So this is the queue, linked list data structure. We can follow array. Here shuffling is required. So if you are adding this and if you are removing this, I think shuffling also, all these elements move to somewhat forward, right? Once the service is done, so remaining, imagine 0 1 2 3 4, five elements are there. So once that first element processing is done, remaining three elements I need to move forward, right? In that case shuffling is required. So time complexity is somewhat high. Here I can say these 2 points are valid. So if we can implement queue using linked list, memory will be extra, and second point is time complexity also it will take somewhat high. Why? Because so once you are processing is done, remaining elements you need to move forward with shuffling. So if you are implementing linked list, so there is no shuffling. So if you directly, once this is done, remove the link, then this is the next node. Once this is done, remove the link, then this is the first node. So that's removing the link is enough in, if you can implement queue in linked list. But in array shuffling is required. So that is the some important difference you need to, remember, and you need to know. So what is the difference between stack and queue when you are trying to implement with array and linked list? Now let me try to explain about what are the methods present inside queue and what are the methods present inside stack. So stack we have some important methods like, so you can write name here first. So first one is stack and queue. So important methods. So first one is by using push method, how to add element into stack by using push, how to remove element from stack by using pop, how to get. Pop method will remove and return. So remove and return top element, but I don't want to remove, but I want top element. In that case peak is the method that exists inside stack to access top element, but it won't remove. And one more method, if you want to check stack is empty or not, is empty. So anyway, when I'm writing the example, I will show you the documentation, what are the methods present inside stack and queue also. Is empty and size. push, pop, peek, is empty, size. These are the some important methods in queue also. So in queue, for adding element, we have method called offer. So second point, if you are removing element from queue, we have method called poll. So same peak also. I mean peak means it won't remove but it will return. In queue also we have peak. Next one same also. If the queue is empty or not, we can apply is empty or not. And for size. So some extra methods are there along with these five. So when I'm trying to explain about, I mean writing the code in queue, I will show you the documentation. So and moreover that in stack, insertion and deletion will be happen only at one end. So if you can imagine this is the array, so one end will be closed. So adding will be at one end, removing will be at one end. So if you have to add 1, if you want to add 4. So first I added 4, then 8, then 9, then 6. So if I want to get 4, so first I need to remove this one, then only I will go. I will remove first. I mean this is called push, this is called pop. So once I remove 6, then remove 9, then remove 8, then I will go to 4. So directly accessing 4 is not possible. So that is the behavior of stack. So queue is two ends we have. One is called entry and exit. So this is called entry and this is called exit. I mean exit. Exit. This is called entry. So we can add element always at entry point and exit point we can always remove. Here we can call it as offer means adding, poll means removing. So in ArrayDeque and queue implemented classes are PriorityQueue, LinkedList, ArrayDeque, right? ArrayDeque you can element add in both ways. So that is the specialty of ArrayDeque. So queue means this is the queue. So first in, I mean first in, first out. This is the first approach. I mean first I can say implementing of linked list. So either it may be array or linked list. This is the first approach. First in, first out. Standard approach. In second approach, priority queue. So in priority queue, some elements are there already. So if you want to process highest priority element first, so that highest priority element at last, I mean it comes and I mean at last. So then we will process this highest priority element first. This is the behavior of priority queue. Highest priority giving, I mean who is having a highest priority, you can serve first. And third one is ArrayDeque. So ArrayDeque is nothing but we can add elements at both ends. We can remove elements at both ends. You can add here, you can remove here. You can add here, you can remove here. That is the behavior of ArrayDeque. So I will write the example about this ArrayDeque. I will explain. So for this ArrayDeque, some special methods are there. Add first, add last, add remove. I mean add first, add last, remove first, remove last. This kind of some special methods will be there. So now let me try to write code for. Anyway, I explained at the time of list in explaining list implemented classes. Stack is done. Now let me try to write code for priority queue, linked list, and third one is ArrayDeque. Now let me try to explain about queue interface and its implemented classes. So for that I already created one package called queue. Inside that I created three classes like queue example, priority queue example, ArrayDeque example. So now let me try to explain one by one. So queue, let me start with queue. So basic queue means I am trying to consider by using linked list. So if you are trying to implement a linked list for queue interface, so queue is the parent reference java.util. So I am trying to add a string, I mean string elements I am trying to add inside to a queue, and implemented class is linked list. So in this case, internal data structure will be double linked list and insertion order maintains. Duplicates allowed, null values allowed, offers constant time performance for adding and removing. So constant is nothing but big O of n. Why? Because at the end we can add, at front we can remove. So there is no extra time, right? That's why always big O of n, constant time complexity. So priority queue, internal data structure will be binary heap. So elements will be inserted depending on, if you don't specify any comparator, then it will be natural sorting order. So if you want to customize, then you can use comparator and you can write on your own sorting order. So duplicates not allowed, null values not allowed. So I mean performance will be logarithmic. I mean time performance log n, I can say. So and for adding and removing elements, for constant time for accessing elements, I mean constant time, I mean big O of n. So ArrayDeque, so ArrayDeque underlying data structure will be resizable array. So what is the specialty of ArrayDeque? You can add elements at end, we can remove element at end, but we can add at front, we can remove at front, both ends insertion and deletion is possible. That is the important point you need to remember with ArrayDeque. So insertion order maintains, duplicates allowed, null values allowed. Performance, so constant time performance for adding and removing. Why? Because at end, at remove, we can access and we can remove, right? That's why big O on time complexity. Now let me try to write examples. So how to add elements into a queue by using offer method, right? So queue dot offer. So I am trying to add one more element, offer. So these are the three elements. How to check this? I mean, queue is empty or not, or if, how to access elements from queue by using poll, right? So I am trying to access elements, all elements one by one by using while loop. So first I will check that queue is empty or not, then only I will access the elements. Let me show you that logic. So first I will apply queue dot is empty. If it is empty, it will return true. If it is not empty, then only I am trying to access the element. So how to access elements from queue by using poll. Now let me try to run it. So adding the element and accessing the elements. So it follows, I mean first one, what is double linked list? Ordering maintains the insertion order. So first I added Java, then Spring, then Spring Boot, then first queue is FIFO, right? First in first out. So Java is first added, then Java first I mean I printed here. So that is the queue behavior. Then next one, next some extra methods are there, right? So let me try to write remaining methods as well. So one more is poll, right? So instead of iterating all at a time, let me try to print first, then I will explain about size, peak, these methods. So q dot size, I mean how many elements are there. So if I can apply poll, so q dot poll. Now if I can print one more time, q dot size. So first time I will get 3. Once I remove it will be 2. Then size will be 2, it will print. So 3. Why? Because here I removed. Remove and return. If you can observe the documentation about poll. So remove here in this case return type is string. It will remove and return. So if you want to see that, so poll method now. So which element it is removed? Let me show you that. So it is removed Java. So that's why we got size 2. So that is about size and poll. If I can apply peak instead of poll, so it won't remove. Now you can observe that size 3 and 3 if I can run. So even though I got the element Java, but size remains same. Previous before I mean before applying peak, after applying peak remains the same. That is the difference between peak and poll. So adding, removing, getting, is empty, size, these are the some, I mean main methods. So next one is priority queue. So priority queue means the name itself indicates that it will process the element some priority. So let me try to implement that. So first I am trying to implement, I mean create some main methods. Here I think already main method is there. Now let me try to implement the priority queue logic. So priority queue I will create first priority queue. So from java.util import, I mean try to import from write package, otherwise you will get some unexpected behavior, I mean not unless unexpected behavior, so you may confuse. So here in this case I am trying to provide strings. So priority queue new priority queue. So how we can customize the sorting order I will show you. So here I did not provide any sorting behavior. So sorting behavior comparator you can pass here, with constructor you can pass. So then it will act, I mean process the element depending on that sorting order. Now default I am leaving. So by default it will maintain natural sorting order, I mean ascending order. Now I am trying to add elements inside that priority queue dot offer. So I am adding some task one with the min priority, some string I am trying to provide. So pq dot offer task 2 is some mags. So priority queue dot I am trying to add three tasks. So depending on priority the task need to done. Average priority, max min instead of average I can say normal priority. So these are the three tasks inside that queue. Now I need to process all these, I mean tasks depending on priority. If I can process, I mean by default it will follow natural sorting order. Let me try to access one by one first. After can implement some comparator custom logic. So here priority queue is not empty. Then I am trying to access elements one by one inside that whatever it may be the task string tasks, right? So I'm trying to, so priority queue dot poll. Now let me try to run it. So I think he's not empty, then only, I mean this is the logic I need to update. So by default it will follow natural sorting order. Whatever order I mean I inserted, same order I got it. First I added min, first I print it is min, then max, then norm. So default natural sorting order. If you want to customize this sorting order, now let me try to implement comparator. So for that, first I am trying to create one static method, public static int get priority. So get priority is the method. So here I will pass string. So from the string what I am trying to do, so if s dot contains one of the method present inside string, so contains, I can say max. So if it contains max word, then that is the first priority I need to process return 1. So else if s dot contains, so normal priority, if it is normal priority I am trying to return 2. contains method is typo error. Next one is, so if you can't implement like this, you can implement on your own. By default I'm trying to return 3. So this method I can call inside at the time of creating here. So this is the static method that exists inside priority queue example. Once get priority method is done, I mean depending on your requirement, you can implement that customer, you can implement that priority logic. So we need to call this get priority method at the time of creating priority queue constructor here. So comparator we need to use, so comparator dot, so one of the method present inside comparator is a functional interface, right? So it is having method called comparing. So I am trying to use comparing, then I will call that static method get priority. So static method I will use static method reference, so get priority. So now it will, I mean process the element depending on priority. Previously it will be by default natural sorting order, so min first, max next, norm next. Now expected behavior will be max, norm, min. Let me try to run. So max, norm, min. So the task 2 is the maximum priority, task 3 is the normal priority, task 1 will be the minimum priority. So like this you can customize your first come first serve. At the time of serving you can provide the priorities, which task you need to serve first. So that is about, I mean priority queue talking about priorities. So next one is ArrayDeque. So if you want to observe methods exist inside that priority queue, you can check. So press Control O once you entered into that priority queue. I mean default, I mean documentation about, I mean this is from JDK, right? So PriorityQueue dot class. So inside that, okay, once you entered into, press Control O, then you can see all implemented, I mean all available methods and variables: size, clear, poll, remove, remove, eq, contains, to, array, offer, grow. So n number of method will be there. Check the documentation. I mean for what scenario we can use each specific method. So if we have time, go for each and every method. Otherwise, so offer is method to add, poll is to remove, peak is to get without remove, size is empty. These are the some methods from queue. Now let me try to explain about ArrayDeque. So for that, let me try to create. So what is the specialty of ArrayDeque? So ArrayDeque we can add and remove at both ends. That is the specialty. So here I am trying to take integer. So ArrayDeque new array java.util.arrayDeque. Now let me try to ArrayDeque dot add. ArrayDeque almost by using linked list only. I mean, I mean normal queue. By using implementation will be linked list, but the difference is you can add at end, you can add, remove at end. You can add at front, you can remove at front. So that is the difference. Add ArrayDeque dot add. So add will be there, add all also will there. By using setup, I am trying to add all at a time. I mean multiple values. Now I am trying to print ArrayDeque. So these are the elements. I mean ordering maintains the insertion order. So setup, I mean anyway this is the factory method, right? If we can add one by one only, then we can understand. So ArrayDeque dot add. So 6. So in that case, now let me try to observe 167293. Now it is allows the order, maintains the insertion order. So Next one, let me try to show the documentation about ArrayDeque. So in default initial capacity will be, I think, 16 elements here. So capacity will be 16 elements. So press Control O. So these are the methods present inside ArrayDeque. Poll first, poll last. So if you want, let me try to show you that methods. So add, by default add at, I think, queue, right at the end it will add. So instead of that, what I need to do, I can, so anyway these are adding elements is done. Next what I need to do, so ArrayDeque dot add first 10. Now let me try to run. So first I added queue when 167293. After that I added first, that's why 10 come first. Add first, with the help of add first. Then I can use add last. Now in this case 10 will be the first, 11 will be the last. Add last, I need to update. Add last, add last. 10 will be the first, 11 will be the last. So again, remove first, remove last. I am trying to apply. Remove first. So let me, don't type manually any method. Remove first. I think there is no parameter. Remove first. Remove last. Why? Because there is parameter is, I mean, not required, right? There is no sense. Why? Because anyway we are always trying to remove first element at the time of declaring. Here itself we are specifying the type, but corresponding type we are removing first, we are removing last. Now expected behavior will be after this statement 167293 only. Why? Because we are removing first, we are removing last. So if I can apply one more time, then expected behavior will be 6729. 6729. So this is about ArrayDeque. We can add at end, we can remove at end, we can add at front, we can remove at front. So that is the behavior of ArrayDeque. So I hope you got some clarity on queue interface and its implemented classes like. So queue, I mean, implemented by using linked list. I mean, queue implemented class, first one is linked list, next one is priority queue. So if you want to process the elements depending on some priority, in that case go for priority queue. So if you want to add elements at the end, if you want to remove elements at the end, then go for ArrayDeque. So in these three, priority queue is somewhat important. In many cases we need to implement both, right? So if you want to process the element in the form of queue, and moreover that if you want to provide some priority, priority queue is recommended. So that's why priority queue is somewhat high, I mean, importance you can give. Anyway queue normal, I mean, first in first out. Along with first in first out you can provide some priority. Both ends you can add and you can remove. So that is the behavior of ArrayDeque. So I hope you got some clarity. So if you got, I mean, if you like the content, hit on like button and subscribe Programming KT. Thanks for watching.